Okay, so I've been asked to take a look at 19.2. So this one is a weight is attached to a spring suspended from a beam. At time 0, it is pulled down to a point 10 centimeters above the ground and released. After that, it bounces up and down between its minimum height of 10 centimeters and its maximum height of 26. Okay, so that's really what we need. We need a min and a max, and we need a time. Okay, it's telling us that it's a sinusoidal function. That's great. Okay, and it first reaches its maximum height at 0.6 seconds. So it goes from the bottom all the way to the top in 0.6. Okay, so what I'm going to do here is I'm going to take this information and put it into a sinusoidal equation, which is y equals k plus a times the sine, and then b times x minus h. Okay, so because it's a sinusoidal equation, so we have sine here. This is actually going to set up like a cosine curve, but we'll do it as a sine curve and just shift it over. It should always work. All right, so our min is 10 and our max is 26. Okay, so I'm going to find the midline by finding the average of these. That will be k divided by 2 equals 18. That is what k equals. That's our midline. Okay, now we're going to find a. And a is the distance from the midline to either the min or the max. Okay, so I'm going to take 18 minus 10. That's the distance from the midline to the minimum, and that equals 8. That will be a. So I have my k, my a. Now I need my b and my h. Well, we'll figure out the h first. But what I'm going to do is I'm going to set up a graph with this information here. Okay, so we'll slide up here, set up a graph. Just do it right here. Let's extend that down. Good. Okay, so there's our graph. We have our minimum at 10, our midline at 18, and our maximum at 26. Okay, try to make that all look even, but we'll see. Okay, good. So I like to dash my midline typically. Okay, my min and my max are there. Okay, so this is time, this is height. Okay, so my time at 0, I'm at a height at 10. My time at 0.6, I'm at a height at 26. So my time at 0.3, halfway through there, I'm at my height of 18, which is k. All right, so basically my each notch is going to be 0.3. So 0.3, 0.6, 0.9, 1.2. Okay, and that should get one sinusoidal curve. So I go from the bottom to the midline, to the top, to the midline, down to the bottom. I could go back to the midline. That would give me one sinusoidal curve. This is going to give me a cosine curve right here. So that'll be at 1.5. Okay, so taking a look at this curve, it's going to look like this. Right there. And now I need to find the equation of this. Well, by going from my top to my bottom there, I could find my h, or my phase shift, where this shifted over. So that is h. H is right here at 0.3. Okay, now I need to find b, which is 2 pi over the period. Now, 1 period is the distance from the start to the end, okay? And on a sinusoidal curve, it'll be from 0.3 right there to, I go to the top, to the bottom, back to the middle, to 0.15, okay? But it's also a cosine curve is from 0, from the bottom all the way to the top, back to the bottom, 1.2. So you can see the distance from 0 to 1.2 is 1.2. The distance from 0.3 to 1.5 is 1.2. So that's going to be our period. Okay, so our period equals 1.2, and our B equals 2 pi over our period. Okay, 2 pi over P equals B. Or, excuse me, period equals 2 pi over B. So here we go. Sorry. It ends up being this way anyway. Okay, so the period equals 2 pi over B equals the period. Well, take a look at this. Multiply the B over, I get 2 pi equals 1.2b, and then I divide by 1.2, and I have that. So I've got my B equals 2 pi over 1.2. Okay, so it worked out the same way. All right, so now we have all the information. We've got y equals k, which is 18, plus a, which is 8, right? The amplitude up and down is 8, times the sine of b, which is 2 pi over 1.2, times x minus 0.3. And that's our phase shift is h as well. Okay, so I hope that helps. If you want to graph this, which I did for the part F, find how many happen in 10 seconds. Okay, how many times it hits 22 centimeters in 10 seconds. I actually graphed it on my calculator, and what I did was I made sure my calculator was in radians, and I set up the x min and max. So my x min was 0, my x max was like 15. No, my x max was 12, I think. Anyway, because I wanted it to be divisible by 0.3, which 15 is as well. Okay, so I had x min at 0, x max at 12, y min at 0, y max at 30. And then my scale on my x was at 0.3, and my scale on my y was at 1. So it worked out very nicely. And then it just graphed y equals 22 and saw how many times it touched the graph, just counted them over between 10. And I believe the answer was 16. Okay, very good. Good luck. Finals posted. Go do it.